From your news feed to a loan application, algorithms are kind of the invisible architects of our digital lives. But what happens when these super powerful tools inherit some of our oldest, most human problems? Today, we're going to dive into the hidden code to understand the huge and often unseen impact of algorithmic bias.
It's a simple question, right? But the answer is, wow, is it complex? Every single time you use an app that recommends a song, or suggests a job, or even tags a photo of you, you're dealing with a system that's made a judgment call. The real question is, are those judgments always fair?
So what exactly is algorithmic bias? It's really important to get this. We're not talking about a random glitch. The keywords here are systematic and repeatable. It's a pattern, an error that creates unfair results again and again and again. It's basically a thumb on the scale, but it's written in software.
And this is the part that you've really got to wrap your head around. It is so easy to think of algorithms as just neutral, objective math. But they're not. They're built by people, they're trained on data from our world, and because of that, they can absorb, repeat, and sometimes even amplify the biases that are already out there.
Okay, so if bias is seeping into these systems, where is it actually coming from? Well, to figure that out, we have to go back to the source. And it turns out the ghost in the machine, well, it's us.
I know, this looks ancient, right? But the principle is exactly the same today. This is a punch card, one of the first ways people gave computers instructions. Every single hole in that card is a decision that a person made, a choice about how the machine was supposed to think.
And let's jump forward to a slightly more modern view. This is a flowchart from 1969. You can think of it as a map of someone's reasoning, with all of their assumptions and their blind spots just translated into a set of rules that a computer follows perfectly. Flaws and all.
So this whole process basically introduces bias in a few main ways. First, the data itself can be biased. If you feed an AI historical data that's full of inequality, well, the AI is going to learn that inequality is the norm. Second, you've got human design. The choices programmers make, what's important, what's not, that embeds their own worldview. And finally, sometimes the tech just has limitations that accidentally lead to unfair results.
Now, this is not just some theoretical academic problem. When these biased systems are actually put to work in the real world, the consequences can be devastating. Let's take a look at what happens when code actually discriminates.
That phrase right there, guise of objectivity, that's the whole ballgame. Because we tend to trust computers, we don't really question a decision if it comes from a machine, and that lets discrimination hide behind this mask of being technical and neutral, which honestly just makes it so much more dangerous.
And one of the most high-stakes arenas where these algorithms are being used is inside our courtrooms to try and predict whether a defendant is likely to commit another crime. So what does this number mean? Well, an independent investigation looked into a really popular risk assessment algorithm, and the results were staggering. The program was 77% more likely to incorrectly flag black defendants as being at a higher risk of committing a future crime than white defendants. And this just lays the disparity bare. The researchers found that when the algorithm was wrong, it was wrong in a biased way. It was twice as likely to falsely label black defendants as high risk, while at the same time being twice as likely to falsely label white defendants as low risk. So even the errors themselves were biased.
And this issue of biased tools in law enforcement doesn't stop with risk assessments. Let's switch gears and talk about another huge technology, facial recognition.
So a huge study back in 2018 found absolutely shocking differences in accuracy. For lighter-skinned men, the error rates were tiny, less than 1%. But for darker-skinned women, some of these systems failed up to 35% of the time. I mean, let's be real, that's not a small difference. The technology is fundamentally broken for an entire group of people.
And we're not just talking about numbers on a chart. These failures have real-world victims. These high error rates have directly led to innocent people, especially black men, being wrongfully arrested based on absolutely nothing more than a faulty computer match.
And this problem is just everywhere. Amazon had to ditch a hiring tool because it taught itself to penalize resumes with the word women's. A major healthcare algorithm was systematically giving less care to black patients who are actually sicker than their white counterparts. And in finance, studies keep showing mortgage algorithms discriminating against minority applicants. It's in our jobs, our health, our homes.
So the obvious question is, if we know all this is happening, why can't we just go in and fix it? Well, the reality is, there are some really big hurdles to making these things fair.
Let's start with something you can actually understand. You look at a flowchart like this and it makes sense. You can follow the logic, the if-then statements, but the systems we rely on today are almost never this simple.
They become what experts call a black box. Basically, we can see the information that goes in, and we can see the answer that comes out. But what happens in between is a complete mystery.
So why is it a black box? Well, a few big reasons. First, just the mind-boggling complexity. Facebook, for example, uses over 100,000 factors just to build your newsfeed. Second, this code is worth billions of dollars. It's a trade secret. And third, these systems are constantly being tweaked and updated. So it's like trying to hit a moving target. And that's the central problem, right? The same complexity that makes them so powerful is exactly what makes them so hard to check up on.
But hey, these challenges aren't impossible to overcome. Across tech, activism, and government, people are fighting for real solutions. So what does the path to a fairer future actually look like?
Well, there's no single magic bullet here. The solution has to come from a bunch of different directions at once. It means building new tech that can audit AI for bias. It means demanding more transparency, with things like model cards that work like nutrition labels for algorithms. It means passing smarter laws to hold companies accountable. And, this is a big one, it means making sure the teams that build this technology are just as diverse as the rest of us.
Look, if there is one thing you take away from all of this, please let it be this. Technology is a tool, but it's a tool made by people, and it's shaped by our values. It is never born neutral. It always inherits the biases of the world it was created in.
In the end, what algorithms really do is hold up a mirror to our society. They show us all the patterns, all the prejudices hidden in our data and in our decisions. So the ultimate question isn't just about how we fix the code. It's, if we don't like the reflection we see in that mirror, what are we willing to change about ourselves?